To be invited to speak with you and to share the podium with Dr. Insel, with Patrick Kennedy, with all of these fabulous and intelligent colleagues. And I've adjusted my talk 3 times now to meet the demands and ideas of the audience. I am not going to play any games. I'm going to talk about what your brain needs to eat so that you can play the games and discuss modern fats in the modern mind. This is my political and public health service agenda. I would like to see every person with a mental illness be referred to a dietitian. And I would like to see dietitians take it seriously so that some person with a mental illness who comes into their care, that they get good professional advice. Why worry about food and dietitians and mental health? Because nutrition does not stop at the neck. 20% of our heartbeat goes to our brain, and the brain is an incredibly complex metabolic organ that has very unique nutritional needs. People with mental illnesses also need specific nutrition education focused to their needs. They need low-income solutions. They need simple, clear advice. They need it predominantly and proportionately for the medical illnesses that they suffer. 2.5 times greater risk of dying from cardiovascular disease, from pulmonary disease, from diabetes amongst people with mental health. These illnesses are all diet-related and diet-treated. So even before we get to the question of what specific nutrients may help above the neck, everyone with a mental illness should be referred to a dietitian to help below the neck. Finally, in 2015, the Lancet Psychiatry recognized our statement from the newly emerging International Society on Nutritional Psychiatry that compelling and emerging evidence suggests that diet is as important to psychiatry as it is to cardiology, endocrinology, and gastroenterology. So understand that we are still a new science, and we are still a new field, and we're trying to, release the shackles of orthomolecular psychiatry in the 1970s and get to better data. Why worry about the brain and nutrition? The traditional view of diet in the last century has been all about protein. This animal has a lot of protein and grows from birth to 1 ton in 3 years on this diet of grass. Now, humans evolved not eating grass, but evolved on seacoasts where seafood and omega-3s were abundant. And many evolutionary theorists state that the ability for human beings to have disproportionate encephalization and big brain is because we had lots of omega-3s available in our diet to supply the brain. That animal that only ate grass is only able to develop a brain the size of the fist. Why? Because the fatty acids in the brain are essential fatty acids. They can only come from the diet. You've seen a lot of beautiful pictures of data, and you may think that a brain is just data or electrons moving around. No, the fundamental reality, as we discussed, right, is the brain thermodynamics? No, what is the brain? The brain is fats, and the brain is oils, 60%. And it's got water and a few little neurotransmitters floating around in that mess. So here in human development, for example, we see that the hands are very different. The mom's hand has grown large, but at the same age of life, their brains are already about the same size because there is a fundamental priority for nutrition and human development in the development of the brain, and we require essential fatty acids to make the brain. Here's your biochemistry introduction for lunchtime. It's going to be fast. There's a saturated fatty acid with lots of carbons saturated with hydrogens. You can unsaturate them and get a mono or one unsaturation, or you can polyunsaturate them. And that's what a polyunsaturate looks like. So from this end of the fat molecule, 1, 2, 3 carbons from the end, or the omega, is the double bond that can only be put in these fatty acids by plants, and only in leaves. Humans can't put them in there. And further down the chain, there's the omega-6 that gets put in the fatty acid by seeds. And down here are the fruits. Humans can also put omega-9s in here. So olive oil and oleic acids are omega-9s, like that. So now you understand fatty acid chemistry at its fundamental and basic. But it's really important. So these two fatty acids, this beautiful and elegant 22 carbon long fatty acid with 6 unsaturations, is concentrated in very important organs: the brain, the retina, and the testes, and also ovaries, fertility. It's rich in seafood and breast milk. So is EPA. They can be converted a little bit from precursors in flax and olive oil through the FADS enzymes. This enzyme is, however, currently absolutely overwhelmed because of the 20th century's reliance on seeds and seed oil, giving this omega-6 fatty acid, linoleic acid, that gets converted to the very famous and the very potent arachidonic acid, which is the precursor of an accelerator of all things inflammatory. So, and it's an essential fatty acid. So you can choose by what you eat as to what you become and what your inflammatory potential is, not only of your body, but of your brain. So here's a sort of my description of this, as if you were eating a Mediterranean or a Japanese diet. You'd have lots of those blue omega-3 fatty acids stuffing into your membranes, creating the biophysical reality of a membrane and determining how these, not only ions, but also receptors, are able to push against it and act. So in the US diet at the end of the 20th century, it's full of these red omega-6 fatty acids. So consider the ligand comes and hits the receptor, it opens the receptor up, it makes signal transduction happen, and it digests. It's promiscuous, and it just digests what's in front of it. You get lots of red omega-6 fatty acids put out because of what you eat. You create huge inflammatory cascades, and you try and put a finger in the dike like the Dutch boy, have a $10 billion or more industry in trying to stop arachidonic acid from flowing with NSAIDs and other drugs. And in contrast, you could eat a diet of evolution or Mediterranean that has lots of omega-3s, and the omega-3s are released, and you get less inflammatory fatty acids that are protective of the heart. Now, not only are these eicosanoids produced, this omega-6 fatty acid is the precursor for marijuana-like molecules. And you can triple the levels of marijuana-like molecules produced in the liver by moving from this diet to that diet. And I can argue to you that the seeds and the omega-6s have in fact made everyone a little bit stoned and a little bit too hungry and a little bit too hyperendocannabinoid. In contrast, when the fatty acids are blue omega-3s, we make an analog identified as synaptamide, and the receptor for this has now been identified, GPR 110, and it, at nanomolar concentrations, makes new synapses and sprouts new neurons. So you can choose with your diet whether you want to be marijuana-like or have the capacity to grow new neurons. So I didn't know, the scope of this audience, but I think this is a fundamental sort of overall perspective. And I like to give this analogy of the seed and the soil to say the relative importance of fatty acids. Well, okay, if you're going to grow a tree, the seed is the genetic inheritance and its potential, but it has to land on soil, and the soil has to be fertile, and then you have to nurture the soil with sun and rain in order to grow a tree. Well, if that tree happens to be a neuron, we have a pretty good idea what the genetic inheritance would be. And I'd say that the sun and the rain is family love and social learning, and I'd go for camping and scouting activities instead of gaming myself. But, you know, those social influences that grow neurons. Well, what about the soil? Well, I would say the soil are the essential brain nutrients. And if you're missing any one of those components, you have bad seeds, you've got family chaos, or if you've got poor soil, any of those three can cause a poor brain growth or poison the soil with lead. So this direct analogy is our neurons grown in cell culture given adequate DHA, 22 carbons long 6, versus one double bond different, 22, 5, and 6. Here are the cell bodies, the neurons, and the synapses. There are 50% fewer branches, neurons, and synapses in this neuron resulting from one double bond different. Right? So think, this is the fundamental unit of the nervous system. You can't process game information through this neuron. You can't process love through this neuron. There are no synapses and no connections. Now, directly, we talked a lot about reward and happiness and games. Well, here's the dopaminergic nervous system of animals raised mimicking these diets from the earliest 20th century to the end of the 20th century. So here's the ventral tegmental area and the substantia nigra, heavily dopaminergic neurons on omega-3s and no omega-3s. There are half as many dopaminergic neurons. So if you're eating a garbage diet with omega-6 fatty acids, you know, what's the background of the basic physiology of diet you want to start with when you give people psychotherapies, when you give them gaming therapies, when you give them pharmacological therapies? I posit that you're probably going to do better with neurons that look like this, that are normative. So that's a basic biochemistry background in philosophy and concept. In 2015, the U.S. Dietary Guidelines for Americans, the federal agency that sorts through all the diet information, did a remarkable thing. For the first time in 2015, they recognized that mental health outcomes were a part of diet. I mean, come on, 2015. But at least they did it. And they recognized that, you know, just like diet should affect your heart or diabetes, that diet is going to have some kind of effect on mental health. So they recommended a Mediterranean dietary pattern, because it seems to be pretty consistent for other things. Fish 2 to 3 times a week, olive oil, the fruit oil, not vegetable oils, and there isn't too much there. Now, I hate dietary patterns because I'm a molecular biologist and a chemist, and I want to know what specifically behind the dietary patterns are the molecular actors. So when they made this recommendation, they literally only evaluated manuscripts and publications if it said dietary pattern. And just on that basis, they had a pretty good idea that Mediterranean dietary patterns would help. So I wanted to unpack the data, and it's a good review for the last 23 years I've been working in this field as to where we're at. Well, let's just go the first level down and ask about epidemiology of fish consumption. If dietary patterns, how about fish and olive oil? Are those the specific foods? Well, a meta-analysis of 26 trials, 150,000 subjects indicate that there's just an epidemiological association of greater fish consumption and a lower risk of depression at 0.83, good solid epidemiological levels. Let's go down another level. Let's look specifically at blood as a biomarker of fish intake and neurological health. Well, here's a meta-analysis of 14 studies with 3,318 participants indicating that higher blood levels of omega-3s are associated with lower risks of depression with an effect size of 0.85, which is massive for clinical effect sizes. Well, let's go down further. let's look at the established data of randomized placebo-controlled trials. Not one clinical trial, but a history of 20 years of randomized placebo-controlled trials. Now, there's been 6 meta-analyses published. Of course, ours is the best. So we did this with John Davis, who originated the catecholamine hypothesis in the 1960s and originated meta-analyses in medicine. And we looked at 52 different study conditions with 11,038 subjects and found that participants who were given an EPA-rich diet and actually had symptoms of major depression, the effect size was 0.61, which is huge for clinical treatments of depression. I'm going to talk to you a little bit more in detail about multiple synergistic biological processes that are aided by the right omega-3s or impaired by a deficiency of omega-3s. So it's not one neuron, it's not one receptor, it's multiple biological processes in the brain that are simultaneously being affected. There is very little data looking at specifically the role of lowering omega-6s in olive oil. One study by Wolf indicating that olive oil instead of vegetable oils was associated with lower depression. This is the reality of the world. These units are not in micromoles or nanomoles. These are in units of 323,000 million metric tons. 322,000 million metric tons of soybean oil was consumed in the US in 1999. We looked at the consumption disappearance of 273 different foods every year from 1909 to 1999 in the US. Soybean oil was not consumed in the US in 1900, nor had it been for the evolution of the nervous system going back 500 million years into the sea. Now the soybean oil creates about 20% of our calories in the whole food supply in the US, and about 8% of the calories that we consume are a single molecular species, that linoleic acid that makes arachidonic acid that causes inflammation. I posit that this is the biggest change in the diet of Homo sapiens since the development of agriculture. And I have no, if anyone wants to challenge me on that, we'll talk quantities. So one of the things we've done in our lab is to use animal studies that then test these epidemiological conditions and actively test differences from 1% to 8%. And I hope to get to some of those data. So that is the background for me to let you know that these dietary changes can cause membrane changes that affect multiple levels of biological processes involved in both addiction and depression. So I like to talk about pleiotropic nutrients instead of dirty drugs. Let's talk about pleiotropic nutrients that have multiple mechanisms of action. And here's some relevant to addiction and depression. My institute studies addiction. We know that dopamine depletion is central to addiction, and CRF excess and stress vulnerability is central to addiction. How would it be possible to design one drug that affects these two vastly complexly different biological systems? Of course, in addiction, it's worse because we've got contributing factors like suboptimal development of the frontal cortex, neuroinflammation, endocannabinoid hyperactivity, and pain. Well, let's look at these fatty acids. And now you're familiar with the blue omega-3s, what I mean. These dietary changes, one impact even before getting into the membrane, this linoleic acid, especially when it's fried in fryers, makes oxlams, oxidative linoleic acid components that hit the TVRP1 receptor and have massive increases in pain. So you get a double dose of arachidonic acid and inflammation and pain and a direct pain. We've been able to reduce chronic headache pain by changing the diet from 23 days a month to 10 days a month, from 10 hours of chronic daily headache pain to 5 hours a day. If pain is driving suicide, that's driving the early die-off of middle-aged white guys, I want to know about this. But I think we are actively looking at the role of these dietary changes, not only in these outcomes, but in pain, which is, I also argue, is a psychiatric disorder. All right, so these diet changes change the membrane. In evolution or in the Mediterranean diet, you get lots of omega-3s, blue in the membrane, in comparison to 20th century diets, lots of omega-6s. There's arachidonic acid. Here's another way to show it. It's a phospholipid on a triglyceride. When the membrane gets activated, the phospholipases are indiscriminate, and they take that arachidonic acid and make it into 2-arachidonyl glycerol, which is the body's own marijuana-like molecule and causes persistent hyperactivity of endocannabinoids. We've shown we can reverse it in humans and animals by reversing time. I showed you instead, if you have omega-3s, you make synaptamide. Another parallel system, which is disproportionately activated in the nervous system by this membrane change, is the neuroinflammatory cascade, which affects microglia and other neuroinflammatory processes. You eat a lot of omega-6 fatty acids, you get a lot of arachidonic acid released, you get fewer resolvins, PG2, neuroinflammation processes, threefold elevation in the gene expressions for CRF. That can be reversed completely by diet. We can reverse a threefold activation of the stress axis and neuroinflammation by diet alone. We think that some of the mechanisms are EPA hitting PPAR gamma and activating NF-kappa B, which inhibits a huge nexus of neuroinflammatory cascades. A lot of drugs to treat diabetes target this receptor, and I'm just, for time's sake, not going to go through all of the mechanisms by which we believe that the omega-3 fatty acids are responsible for this phenomenon of the dopamine deficits. Okay, so does it work in humans? This is some of the early epidemiology which paints the picture, which laid ground to test the hypothesis. In countries with greater fish consumption, there was a 50-fold lower risk of major depression across countries. We published this in 1998. We've gone through the field all the way to meta-analyses of randomized controlled trials. This is the trial I described before, 52 study arms, low effect size. When we sort out those that were EPA-rich compared to DHA-rich, none of the DHA-rich formulations, that is, you have EPA and DHA in the fish oil, which do you have more of? If you have more EPA, more than 50%, those trials worked. If it was more DHA, they didn't. Then when we parsed out amongst those trials, did they actually put clinically depressed people in the depression trial, or did they study somebody else? When they actually studied people with clinical depression, the effect sizes are 0.6. This is going to be published soon in the British Journal of Psychiatry. Other investigators have found this as well. The summary for depression is EPA-rich formulations appear to be effective. Participants must have depressive symptoms. There is publication bias in small studies, and heterogeneity is evidence. We need larger studies. We're conducting them now, but the effect sizes are good in comparison to other therapies. You may hear, one of the questions I wanted to ask the gamers is, what's the effect size of reducing depression or concentration? Is it a small effect? Is it 10%? Are you doubling your concentration, ability to concentrate? So psychotherapy has effect sizes of about 0.2. Most antidepressants have effect sizes 1.3, 0.3. Here we have a pleiotropic nutrient that was always in our diet that we can restore that's having effect sizes of 0.61. Maybe, in another 20 years of randomized trials, that effect size is going to go down. I don't know, but it's looking pretty good. This is what kids eat. Could we extend these concepts and these data from depression to the lethal expression of depression and other psychiatric disorders, suicide? So Dr. Peter Corelli, or General Peter Corelli, kind of came after me, and so did the Suicide Prevention Task Force, and said, okay, if you're going to prevent suicides here, which is a low frequency event, we actually have to target the high risk behaviors of violence and impulsivity and consider it on the effects of the health cycle if we were going to use this to change military diets. So right now, omega-3 fatty acids are recommended for cardiovascular and other benefits by 30 different international scientific bodies on the basis of 9,000 clinical human studies and thousands of clinical trials. But what are the data specifically for this pool of high risk and impulsive behaviors? So I think it helps to summarize the field and where we're at right now in asking that question. I tried to encapsulate it in a little graph here. So here's the disorder, major depression, ADHD. Do we have plausible mechanisms? How many epidemiological, ecological studies have been done? How many case control studies have been done? How many randomized trials have been done? How many meta-analyses have been done? And what's my assessment of the data at this point? I've given you this for major depression, all the way from mechanisms to epidemiology, 6 meta-analyses. I think personally, yes, there's a big clinical effect size. I'm very confident in this. I'm also very biased because I started the field, but that's okay. The data are what the data are. In ADHD, we have plausible mechanisms. There's less epidemiology and case control. There's now 11 RCTs, 2 meta-analyses. They show that omega-3s are effective for ADHD, but not as good as medications. The effect sizes are about 0.3 instead of 0.6. It may be an important complement, but all the trials, there's low heterogeneity. They all pretty much say the same thing. Aggression and violence is really difficult to study, but really important to study. And we've only got about 10 randomized placebo-controlled trials. I'll show you some of this data if I have time, that there's a robust reduction in felony-level violence committed in prisons in good randomized placebo-controlled trials. In consideration of the poor diets that many violent people are exposed to, we have an opportunity for public health here. I think we need more research, but we have an opportunity. There's only a few studies done in alcohol and substance use. I won't show them here, but I will show you more about suicide. So we did the first RCT of subjects with deliberate self-harm, which is close to suicide, in a Dublin emergency room, 49 subjects, 12 weeks, EPA greater than DHA, 2 grams, supplied by the Norwegians. We found a 50% reduction in depression. It was actually a 45% reduction in suicidal thinking, increased reduction in stress, improvement in happiness. We're now moving to try to neuroimage happiness and dopamine release. This led us to actually backwards to a case control study of 800 military suicide deaths compared to 800 controls pulled from the archive of 6.2 million biological samples that the military has contained. And we did a matched by those criteria to determine if low omega-3 status was associated with increased suicide risk, and if lower status correlated with severity of post-deployment psychiatric symptoms. We never could really assess this question well, but we could assess this. And the answer was that, so here's three different levels of the omega-3s here as a percent of fatty acids, and in the lowest level here, 0.7, the odds ratio, the risk of having died of a suicide, was elevated on 1.82 in comparison to the highest group, the highest levels of omega-3 fatty acids, and it was pretty consistent across eight octiles. Now, one important comparison here is that this is the US at the end of the 20th century. So there was a similar study done in China, and the lowest quartile of the Chinese population did not overlap with the highest level of the US military population. And each of those higher levels of omega-3, of DHA in the blood was associated with a lower risk of suicide. So that's the best biomarker data I could put together from 2 dispersed studies, which indicated that there might be a 4 to 5-fold difference in risk by suicide levels. It isn't causal. It doesn't say it prevents suicide. It says we'd better do the study to see if it works. So we're doing the study. We were funded $10 million. By the way, this study cost us $40,000 to identify a risk factor for suicide. It didn't cost us $40 million. It cost us $40,000. And now we're doing an interventional trial based on that biomarker and that biology. It's underway. It's targeting 350 veterans who have recently attempted suicide, and giving them omega-3 fatty acids or a placebo, and determining whether or not it reduces the risk of a new suicidal behavior in the 6 months that we're studying them. Trial is about midway. Another 2 or 3 years, I can give you the answers. We're delivering the omega-3 fatty acids in a juice box of smart fish. There's other great ways of delivering omega-3 fatty acids, and Carlson's is the first fish oil company to join with the psychiatric community in, be here present and offer you materials. So what's the similar biology of these impulsive behaviors? This is my transition from impulsivity and suicide to impulsivity and violence. And it's, of course, damage to the prefrontal cortex. And low serotonergic function in the prefrontal cortex is a common mechanism underlying high-risk impulsive behaviors, as Professor Phineas Gage and his tamping rod taught us. So, if we take piglets and deprive them of omega-3 fatty acids for only 18 days, the first 18 days of life, serotonin in the frontal cortex is cut in half. Dopamine's cut in half. HVA is cut in half, just as it is in cell cultures. Just 18 days. So if this continues persistently throughout life, we might suggest that frontal cortexes are insufficient in these neurotransmitters. We would then predict that giving the omega-3 fatty acids back would reduce impulsive behavior, reduce aggression, and other problems. So we did a randomized, double-blind, placebo-controlled trial with Adrian Rain, 95 in the omega-3 group, 89 in the placebo group, and this was a community sample, just normal kids. They happened to be in Mauritius. Again, we happen to use in these studies the smart fish. So the fatty acids were given for 6 months, and then we followed them up for an additional 12 months. These are the children's ratings of their own aggression, proactive aggression here. That is, what are you initiating versus reactive aggression. If you're provoked, do you aggress? The effect sizes are about 0.5, 0.6 at 6 months and come back to baseline at 12 months. It extends differently to the parents and the teachers' ratings of the children. Here for the rating of delinquency. And the parents and the teachers didn't really see a difference in the 6 months the fatty acids were being given, but they saw a difference 12 months, a residual effect. And again, the parents' ratings extended in the same pattern to all the parameters, to internalizing behaviors, to externalizing behaviors, to ADHD symptoms, and to a really interesting parameter for those of us who love to study violence, callous and unemotional behaviors, which is, sociopaths or politicians. We have a hard time changing callous and unemotional behaviors. And we did it here. It really surprised us that we would possibly find an answer. So this seemed to be the key of the difference between the 6 months and the 12 months time. We gave the omega-3 fatty acids to the kids, their behavior improved, and the parents' psychopathology improved. Right? It's no mystical transformation of omega-3s moving from one person to another. Your kids behave better, you behave better. And we found remarkably this difference in parents' psychopathic inventory with large effect sizes. And I think that if I might be so bold as to dream, to say this is probably the first evidence of a spreading effect of quieting down the most disruptive individuals in a population and sort of letting the peacefulness extend. This was the study I alluded to on the reduction in felony-level violent offenses in prisoners. It was done in 2002 by Bernard Gesch. 318 offenses among 172 prisoners. Looked at violent offenses at baseline. And the outcome parameter here is interesting. It's a new conviction for felony-level violent offenses committed in the prison. A new conviction, not did I feel better, or did you get convicted or not? So it has economic consequences. So 72 cents a day of omega-3 fatty acids reduced felony-level violences by 37% in this trial. You can feed a lot of prisoners for reducing one event, 37%. Now been replicated twice in prison populations, and of course, none of them have been done in the U.S., so it really doesn't work, right? Because it's not done in U.S. populations. It's all foreign populations. So we can play around with the epidemiology to have a look, and so I've done that. We'd predict that there would be lower homicide mortality in countries that consume fish compared to ones who don't. The association is about a 30-fold association of greater homicide mortality. And I do weird things. I'm an omnivore for data since I'm a psychiatrist, and this is being funded by Catholic Charities. So let's not ignore this data. That the first mental health dietary recommendations issued 2015 years ago, actually formalized in 1242 to 1246 in Vatican I, was the consumption of fish 2 to 3 times a week, reduction of meat, and basically also following a Mediterranean diet. I calculated it out. I did a dietary survey, calculated out about 2 grams of omega-3 fatty acids a day, which is about biochemically what we find to be correct. At any rate, it's just perhaps only speculative and interesting that the Prince of Peace is associated with fish consumption. It's just, I don't know how to do the randomized trial, right? At any rate, so we're back to this, and we're back to this competition bit, with the omega-3s and omega-6s, and they're active. So here, 1963, also old stuff. How do you get more omega-3s in your blood? Here's DHA, for example, right? Why is DHA going up in the blood from here to here? Because the amount of omega-6 fatty acids in the background diet are being lowered from what we find in the 20th century out here to what we find in evolution here, and the metabolism is freed up, and the DHA is doubled, and the EPA has 5 times as much because the omega-6s are lower. So again, right, we've flooded the country in our brains and all our kids' brains with lots of omega-6s. It's associated with homicide. How do I fix my omega-6 to free my omega-3? I tried to give a practical outcome. How do you do it? Well, you can nix the 6. You can avoid sunflower, soybean, corn, and sesame oils. Canola oil is better. Eat everything with olive oil, and I don't have the data for coconut oil, but it's just fine. It's low omega-6 fatty acid. I'm in the camp that believe that saturated fatty acids are irrelevant for heart disease. I've been there for 20 years. Now the dietary guidelines have caught up. So olive oil, coconut oil, that's great. So here's, I think, the biomarker you want. One way to express it is the omega-3 index. One way to express it is, are your omega-3 fatty acids and 6s balanced? Here's 50-50, which would be a Mediterranean body level. Right? There's the US military. They're at about 17%. They're pretty bad off. So how do you do it? Okay, if you have a soybean oil background diet with 8% linoleic acid, you can eat more omega-3s and build your blood levels up to get to there. You need about 2,000 milligrams a day. You can just buy them straight as fatty acids from Carlson's, from Barlean's, from Trader Joe's, Nordic Naturals. A lot of people eat a lot of fish. Now, if we switch and follow a Mediterranean dietary pattern and avoid seed oils and eat fruit olive oils, lowering the omega-3 to here about 3% of calories, then that same amount that you take in the body really markedly has a bigger impact to elevating your blood levels. Here you'd only need about 1,000 milligrams a day. So half as many fish from the sea, nice sustainability connection there, by lowering the omega-6s, by going from soy to olive, which is following the Mediterranean dietary pattern. If you want to get capsules of omega-3, EPA, and DHA, if you have unconcentrated fish oils, you need about 7 caps. If you have molecularly distilled fatty acids, they're concentrated, you need 4 caps. If you want to prescribe Lavazza for triglycerides, hypertriglycerides, or use it as an off-label product, you need about 2 capsules. If you want to reduce your 6s, this is the quick fix. Get rid of these 10 top most negative foods for Americans. Soybean oil, mayonnaise, tub margarine, microwave popcorn, fake Italian salad dressing. Italian salad dressing should have olive oil in it, not soybean. Potatoes, stick margarine, peanut butter. We're working on peanut butter. So I just wanted to let you know that this is practical to do. And we did it for breakfast and lunch today. And April helped, and I helped. And most importantly, if you really want to get the story here, go to efaeducation.gov. And Bill Lands has really put together a lot of tools and apps to look at your foods and help you make your choices to get you into the right blood levels. And finally, I wanted to give an advertisement for one of our 8 randomized placebo-controlled trials here in adults with ADHD, where we're using the omega-3 fatty acids and neuroimaging techniques to determine if it's going to restore dopaminergic function. And I wanted to thank you for your kind attention.